Let's go to LeetCode 3342. Find the minimal time to reach last room 2. For this question, it gives us an integer array, two-dimensional integer array move time. And move time ij represents the minimal time in seconds when you can start moving to that room. Um, so, so the things that, for example, this kind of move time ij means the starting time to move to this kind of cell. So that means that is the previous cell's time it can start. So the time around this kind of ij will be the previous time plus the time costed. And for this question, it says that you can uh, move to the adjacent room, take 1 second or for one move or 2 seconds for next, alternating between the two. So for this question, it is seems that it is that you are able to move from the use different times. For example, from the cell 0 to 01, it take 1 seconds, and to 10, it also take 1 seconds. From 01 to 11, it will take 2 seconds. And 10 to 20, it will also took 2 seconds. So we'll say the time, this we'll say this kind of we can call it step length. Only depend on the position. That if the row plus column mod by 2, if this one is an even number, then the next step it take 1 second. If it is an odd number, then it is 2 seconds. So for this question, what we're thinking about is that we use a Dijkstra, use a priority queue to put the first cell 00 and into the priority queue. And for this one, for Dijkstra, we normally don't use a weighted set. But for this question, for this kind of question, if for a row column, a specific row, all of its states has been enumerated, we can still use the set weighted array, right? So this question, as long as for this kind of cell, we enumerate all of its states, then we can use a weighted array to put these kind of states into the set. And the priority queue, the first one, which we have the row column reach the last cell, will be the one which have the shortest time, right? So for the priority queue, we put row, column, and steps, that is the time, right? So in this case, we can write code for this. For this question, we need a private final static and the this is a 13 array, right? And also that D column. So the things that let's have the dimension out and equals. So let's have a priority queue. And we are going to put an array into it. And for this array, every element we are going to compare sort by its time, right? So that it will put row column in the steps or we say time. Then we use a Boolean revisited to offer new and 0, 0, 0, and we'll have set visited 0, 0 equals true, right? So what we say is that while this queue is not empty, then we're going to get int current equals queue dot pull. And we'll get row equals current 0 int column equals current 1. And we're going to have time, right? We'll call stack equals current 2. So at current row and column, how many time we are going to use to go to the next cell? We call it the step length, right? For length equals so that will be current 0 row plus column mod by 2 plus 1, right? So that means if we are standing at any row column, for example, they added that is even number, then we are taking 1 second moving to the next. If we are put in a cell, for example, 2 and 3, they add up to odd number, then it will go to the next cell. It will take 2 seconds. So let's say if row equals m minus 1 and column equals n minus 1, then we just return step, right? And for int k equals 0, it's more than 4 k plus plus. We have int new row equals 0 plus the row k, and int new column equals column plus the column k. And let's say if new row smaller than 0, new row greater equal to m or new column smaller than 0 or new column greater equal to m, then we're going to continue. In the we'll say it's the new step, right? New step will be step plus the length, right? That is reach the new row and column. What's the time to reach? Here, the thing is that we're not comparing the new step with the move time, but we'll have if the move time new row new column is greater than the current step, because that means this is the start time, right? The previous it can begin to move. So it is at this step we are begin to move. So if this kind of so this is not move time is begin to move. It's a previous cell's time. So it's not a new step here. It's a previous step. Okay. So this is the only tricky part for this question. Then we're going to have a new step equals. So that will be the move time. We are able to start from the move time instead of the step. New column plus next, right? So we'll say if the new row and the new column is not weighted, we are going to have queue offer new int new row new column new step, and we're going to have weighted new row new column equals true. So for Dijkstra, is that it's not the first time we did it, because we are not the things that for this kind of position, right? As long as every state we already enumerate and include, then we can put this one as weighted. It doesn't mean that the weighted will always happens before those kind of states is not weighted because the time they are different, right? But the thing is for the cell, we already enumerate all of the states. So remember in BFS, the weighted will always happens before the unweighted cells. But for this one, the weighted may happens after the later include cell, right? Because the state, the weight only mark for this position whether all the states already enumerated or not. So in the end, we return -1. There is the last one. New step. It looks like the second one has problem for the all of zeros. So k smaller than 4k if out of bound. So this is actually n, right? Uh, for this question, let's see, we use a priority queue for Dijkstra. If the worst case is that we for every cell we include, right? And for the include operation, that is log operation. So the time complexity will be m uh n log n, right? Space will m multiply n, right? And Python code will be, let's also write the Python code. So we are going to have D row equals and D column equals 1 0 minus 1 0 and 0 1 0 minus 1. Okay. So what we do is that we're going to have also have mn, right? M n q equals length more time and the length more time 0 and the q. We're going to have a weight equals so will be force, right? Multiplied by n for underscore in range m and related to the 0 0 equals 2. Okay. So what we say is that while true, right? While q is not empty, then we're going to have a step um so because we want to put sort by the steps, right? The time. So for this queue, we're going to put we didn't include anything, right? We want to we need to queue dot heap push heap queue dot heap push queue, right? And 0 0 0, right? We put the time steps as a first element so that we don't need to write a lambda here. So we'll write a step row column equals equal q dot heap pop q. Okay. So what do we do is that we're going to have a step length, right? That is at a current row and column. Go to the next step. What it will take a row plus column mod 2 plus 1 seconds. So that means that if row equals n minus 1 and the column equals n minus 1, right? We just return this step. And for the fork direction, we are going to have a new row, new column equals row plus d row a in the column plus d column a, right? And the new step will be our step plus L, right? So first, we need the row column in bound, right? If new row smaller than 0, or new row greater equal to m, or new column smaller than 0, or new column greater equal to n. We are going to continue. Then we'll say if more time, new row, new column. If this is greater than step, right? We have to wait. So this is a step, not a new step, right? Because that will be the previous time it begin to start to move, right? So that since the new step will be instead of the previous step plus L, we should use the start time. It's not step, right? It's the move, new row, new column, plus L, right? And we'll say if not weighted, new row, um, new column, we're going to have heap Q, heap push, Q, new step, new row, new column, and a weighted new row, new column equals true. And in the end, auto just return -1, right?